Thank you. Moving on, I'd like to introduce Julian Hennessy, who is the Development and Construction Projects Director for Telehouse Europe, and he's going to talk us through some of the challenges and benefits of the refurb of Telehouse South. Julian.
Thank you. Hi, guys. So this one's very, very close to me, Telehouse South. Telehouse South is our 5th building in the Docklands campus. Some of you might be familiar with Telehouse, but I'll go into it in a bit more detail over the next slides. But that's Telehouse South there on the left, or on the right. It was the old Thomson Reuters building, who some of you might be familiar with, in the Docklands campus. And I'm Julian Hennessy, Projects Director for the Development and Construction team in Telehouse. Just a bit of background on Telehouse itself for those that don't know. We are a global data center owner-operator. We have over 3,000 customers globally. We have access to over 1,000 connectivity partners in the Docklands campus, and we're 100% powered by renewable energies in the Docklands campus as well. 45 plus data centers worldwide, 20 cities, some of the major touch points there that you can see in orange across the globe. Over 400,000 meters squared of floor space, 5 nines uptime, and we're the primary home of London Internet Exchange from 1994. Telehouse South itself, so just to go into a bit more detail of the building, as I said, we bought the building in 2020 from Thomson Reuters. Initially, when we got into the building, there was a mixed use, so there was a BH use on the building of 3 floors of data center space and 3 floors of office space / trader space. The upper floors from level 8, 7 and 6 were office space. Levels 5, 4 and 3 were data center space with meeting rooms on level 2. Obviously, our first initial insight into the building was very, very limited. There was a sitting tenant in the building, so we couldn't really get under the skin of the building at that time. So our feasibility study during procurement was very, very limited. From what we could see from the lower floors, the structure seemed sound. It seemed built to a quality that you probably wouldn't really get these days. It was a very famous architect that designed that building, Richard Rogers, who also designed the Lloyds Bank building up in London Central as well by Leadenhall Market. The bit we could see, as I say, from the bottom floors was sound. There wasn't any deterioration in the building fabric itself. It still seemed solid. There wasn't that much building movement that we could see from those initial outset surveys that we could carry out while the tenant was still in place. During that time, we were still toying whether the building suited us or if we could make the building work how it was with the existing structure. There's a very, very big constraint in this building. One of the things is it's a concrete structure, so there's no steelwork columns. It's actual concrete columns. They're 650 mil square, and there's multitudes of them throughout the building that obviously support the structure on the higher levels with the heavy heat rejection units on the roof. One of the big things about it was maximizing the white space from a sellable point of view and from kind of bringing the building up to a Telehouse standard of what we'd expect from across our campus in the Docklands as well. Very, very early on, when the tenant vacated, when our design team got in, it was evident that we were going to keep the building from a sustainability point of view, carbon offset point of view in the area as well for our local residents in the area. It was to minimize impacts on them and maximize environmental betterments and sustainability betterments for the building. So a bit about it. 15 megawatts was the original building itself when Reuters had it. After our design, we're now sitting at a 30 megawatt building, so we've doubled the amount of power going into the building, and that's equaling a 7 megawatt IT load from the Reuters day to an 18 megawatt IT load on full fed out of our deployment. We're redoing all of the office floors, which you'll see in a few later slides, but all of the office floors in the building are now turning into white space with the option of offices / white space on level 8 as well. A few metrics on the building itself. So the gross area is 31,000 square meters. We have 688 footprints per floor. That's in flux at the moment. It's kind of going up a bit from through design, which I'll touch on when we get to the photos at the end. Standard rack sizes is your usual 47U, so 600 by 1.2, 30 megawatts with 2.7 megawatts of IT power per floor. We have a design annualized PUE of 1.24. dual redundant diverse fruit rooted feeds coming from originally now at the moment from Blackwall Way. In the future we'll be feeding ourselves from our own Telehouse owned 132 substation on the Docklands campus. N+1 redundancy on generators with 24-hour fuel storage, and distributed redundancy of 2N to the customer rack across 2 data hall floors. And then N+1 heat rejection on the roof with N+20% on-floor cry units. Our building overview. So in 2022, we opened our original floors that we opened to the market at that stage were level 3 and level 2. So our 2 meet-me rooms on level 2 and our level 3 data hall itself. Reception and the loading bay and storage, that all got a kind of a new spruced up touch just to improve that customer experience in the building. It was very dated, it was very dilapidated. As you can imagine, a tenant vacating a building probably is kind of easing off on the maintenance of the building at the end, and that's what we saw when we got there. So we just refreshed the whole lot from level 3 down while we were in design for the main building deployment. And in summer 2024, this year, we'll have another 2 floors coming out. So level 6 and 7 will be coming to the market at the end of summer this year. And that will be to a capacity of 2.7 megawatts per floor. In way of location, we're approximately 600 meters away from the Docklands campus as the crow flies. We're connected to the Docklands campus by 2 dark fibre routes, as you can see on dark fibre route A and B. There's 3,673 fibre routes on each of those legs, and we have plans to put more of our Telehouse owned duct system, power and comms ducts in during the next 2 years as well. So just on the sustainability approach from the design stages. So as I said, the first initial design stages, we were toying up with whether we remove or we demolish the building and build it how we want to build it, get rid of all those constraints that we would have had in the white space that could have caused a bit of, I suppose, not aggro, but a massive constraint all the way through construction. The risers in the building were probably about the size of this room, and there was 6 of them. So they were big risers that had a lot of future growth. The architect at the time kept the building very fluid. So that was one of the points that we actually hit on in this, reducing 3 of the riser sizes to maximize white space and serve the building through 2 risers in the front in the technical areas. Through design stages with Black and White, our design partners, we now have a new cooling system in the building which is being deployed at the moment. It's currently under testing. Highly efficient free-cooled air-cooled chillers, annualized PUE of 1.24 versus the existing PUE of 1.68. So the sustainability factors coming in here when we start talking about not knocking the building down, repurposing old plant and equipment, removing all of the old kind of real heavy gas-fired generation, which you'll see now. So our approved acoustic levels, obviously we have neighbours around the vicinity as well. We have a hotel beside us and plans for a new residential development right beside us. So we had to take them into consideration, and obviously our local community into consideration during the fit out of this building. So we have improved acoustic levels, massively improved acoustic levels, reduction on natural resources as well. So our cooling system in this building doesn't use any water. So it doesn't use any natural resource for cooling, no adiabatics at all. It's a standalone fillet and it keeps operating as air-cooled. New heating system in the building, so we have completely removed all of the old inefficient gas-fired boilers and water heaters. We have local waste recovery to a water source heat pump that we use to heat peripheral areas in our building, and we have the ability to connect to a district heating system if that was ever called upon by local authority. Upgraded generator strategy as well. We had 30-year-old generator sets in the building that were very, very uneconomical. A lot of, I suppose, carbon was coming from those, a lot of NOx levels put into the local area. We've completely revised that. All of the old generation is removed from site or about to be removed from site. We have a new generator being installed at the moment and under testing. Highly efficient generator sets, so they're 2G generator sets from Rolls-Royce. New SERs, so catalytic converter reduction, 90% reduced nitrous oxide into the area. Urea system, which is AdBlue for a normal car user. and we're exploring HVO with manufacturers at the moment. So during this testing, we actually have 2 sets running on HVO and 2 sets running on diesel, so that will give us good comparable data on which one is the best one to go for. Overall facility improvements then, so as you saw from the office floors, it was glazing from levels 8 to level 5. We're fully replacing the facade from levels 5 to level 8. Level 8 will be getting full highly efficient glazing system put in, and all underneath that will be alley-clad to follow from levels 3 and 4. Full roof replacement with improved insulation thickness, going from 50 mil to 185 mil. So again, increasing U values on the building and keeping all the building more efficient, basically. General improved fabric performance. So anywhere we're going into, we're replacing walls with new walls. We're replacing white walls. Our data hall now has a box-in-box solution where we have our outside cladding. We have an offset of about 300 millimeters. And then we have new white walls installed there now, so the heat gain into that area is minimal from where we stand, and it gives us a bit more tighter control on that environment in there. Strip out of all floors, so we've stripped out all floors in the building. We've removed all inefficient plant and equipment. We have areas, temporary measures, heating and cooling those areas from our existing systems that we're putting in with our new install now. And then external improvements, we have new fuel filling points, we have full drainage replacement across the whole campus. Our stormwater drainage currently exits into the River Thames, so improving that water quality going out into the river was another massive point of ours for reducing our impacts in the existing environment. So we have vortex separators cleaning water going out into the River Thames, as I say, new drainage all across the site. And we have a new sustainable travel plan now worked on with the local authority as well, which really puts an emphasis on bicycles and no parking on site. And again, we're 100% renewable energy fed on this building as well, like our Docklands campus. Our construction stage is currently still in play. We're in the testing side of it now, so we're coming into commissioning and proper level 4 and 5 testing, which was your general IST for the building. On the offset, when we went into the construction stage, we set off to tender with a few parameters about how we wanted the construction to go and to keep that sustainable and environmental approach throughout the construction phase and not just keep that in the design phase. So we set off with a fairly ambitious target for anything that was removed from the building. So all of the recycling and construction waste that's coming from the building, which was a colossal amount, as you can imagine, from a 30-year-old building. We're currently at 97.95% of that. So very little has gone to landfill on that. Our strive for circular economy, again, putting back into the community around us. There was a lot of desks, a lot of chairs. There was a lot of just general building materials that can be repurposed in the industry to really improve kind of our carbon offset for the project. We've donated desks to local schools. We've donated chairs to local schools and offices, and a lot of the floor tiles have been repurposed in the industry. So a lot of them are being reused in other buildings. Green procurement, I'll touch on this a bit more, but every single aspect of this project has been looked at from a procurement point of view. When I say green procurement, it was the most efficient piece of kit. So if it was a cry unit or a chiller, any piece of equipment we were buying for this building has been bought on a sustainability factor and energy efficiency point of view. We've got the best market available technology in the building that we could get. Donations to local charities. So from the offset, obviously we can see and quantify what we can see in front of us, but we can't quantify what we couldn't see. So all of the recycled materials that we could see in the building, we took to the project basically as savings off the bottom line of the project, and we knew there was going to be some flux there. So what we did was we took a really basically once a certain tonnage had been exceeded for recycling materials, the contractor was to let us know, and anything after that was benefit to the local community. We currently on 30,000 worth of charitable donations. So two of our charity partners, First Love Foundation and Leaders in Community, have both got 15,000 each, and we're hoping to give them a bit more at the end of the project as well and work closely with them. Our industry skill set development is a major thing for us. I think from anyone that knows about the data center industry, there is a massive skill shortage at the moment. It was really emphasizing the focus on graduates and apprentices on site. So we have meetings every month with the contractor where they present those figures to us, how those people are being managed on site, how they're being looked after, and how they're being developed properly moving forward. And then reduction of embodied carbons and off-site carbon as well. So on-site carbon was just your general plant movement. Any generators, we don't have any generators on site, but any plant movements of JCBs, anything like that around is all ran on HVO. There's no diesel on site at all. And our embodied carbon account, we're accounting for it on anything we buy, anything we install, and that will all be reported after the project is completed. This is one of the points on the green procurement that I want to touch on because it kind of shows how in-depth we've gone into this. This is just one example of the pipework, and it's something simple that you might think pipework is pipework, but it is a new innovative pipework that Tata Steel have brought out. It's manufactured in the UK. It's called Optimus Carbon Light. It will revolutionise the industry, I think, in the coming years. It gives you all the benefits of any Shed 40 steelwork, which is very thick carbon steel. This is a reduced carbon steel with all the strength characteristics and all the technical characteristics that you'd expect for in a normal data center operator. Just on this case alone, we've seen 515 tons of CO2 emissions saved on this. So just in kind of relative terms, 335 direct flights from London to New York, 118 average cars off the road in a year, and heating of 237 or 34 homes in the UK for a year as well. And then just another little tidbit at the bottom. So just to capture 1 ton of CO2 emissions, we're looking at planting approximately 50 trees for a year to be grown for 1 year to offset that. So 5, 15, 27, approximately 27,000 trees that would need to be planted and grown for a year to offset just one decision that we made on the carbon steel pipework. A few before and afters. So this is level 2. This was one of the first floors that we came to. So the picture on the left is the old MMR itself. That was fully stripped out back to shell and core. All of the slab ceilings were done, all of redecorating, and what you can see as the final product is on the right-hand side there. That's one of 2 of our MMRs in the building. Level 3, what it was a kind of mixture between carpet floor tiles and vinyl floor tiles and missing floor tiles and a lot of damage around the place and old equipment basically. So we stripped everything out of that floor, again protected the floor slabs, fully redeveloped the whole building itself. And I'll touch on the next slide, you'll get to see the kind of riser one board. But that on the right-hand side is the new floor plate, which is coming to capacity now, and the reason that we're coming on to level 6 and 7 being delivered this year as well. Level 6 and 7 were both office floors, so the top left gives you an indication of what they used to look like. They were in relatively good condition for what they were at the age of the building. They've been stripped out now back to shell and core, the same as level 4 and 5, and what you can see on the bottom right-hand corner, the size of the riser has been reduced. It's very hard to make out, but it's been reduced on that data hall itself by about 90%, and on the other side it's probably about 97% the reduction in that riser, which again is maximising our white space in the building, and there was no need for them to be that size in the first place. Level 9, again, looking at all aspects of the building, the mechanical plant wasn't UPS backed in the building, so it didn't have uninterrupted power supplies. It was just generator supplied. So we have now repurposed the old generator room on level 9. We've made that into our new UPS rooms to support our mechanical equipment on the roof and upper levels. And then the last photo is just the roof. So what used to be the roof on the top left with all of the exhaust flues on the left from generators and gas-fired boilers on the right, all of those have now been removed. The full gantry has been replaced, and what you can see on the bottom right now is our new air-cooled chiller solution and the old dry air coolers that are on the right-hand side of that. And that's it from me, guys. Hopefully I haven't bored you all to death with that. Any questions?
Any questions?
Thanks for that, Julian. Very interesting. Steve Wright. I was just wondering what you're going to do with the rest of the power. So you've got 18 megawatts of IT load, a 1.24 PUE.
Yeah.
I make that out to 22, 23 megawatts.
Yeah.
You've got 30 capacity there.
That's our trick in our back pocket, basically. We always keep some for flexible space in the building. So we maximize our flexible space that we have in the building to turn into white space and revenue generation after the fact. But the 18 is just pure install, basically. We have level 8 that's kind of floating in the midriff that could be an office or it could be a data hall. We have a lot of other areas on level 9 and on level 2 as well that are going to be turned into data space as well, or have the potential to be turned into data space as well.
And how's the design PUE versus operational PUE at the moment?
We don't know that it's operational at the moment, but at the moment, even through stage 5 design, we're still sitting at the 1.24 as well. So we touch base with a company that we have, North Shore, and they've ran everything with our existing plant, and it's giving us less than that, but I don't want to publicize anything less than that at the moment until I prove it during testing.
Cool, thank you.
Thank you.
Any other questions? Yeah. Ty, just there.
Thanks. You said you could connect to a district heating system if called upon to do so.
Yes.
How much of your heat could you get rid of that way?
Most of it, to be honest. It depends what call we have. So I think from when we start talking about district heating systems, it's very, very demand. What's near us on that side of the main road that runs through it is very, very little that could connect to us now. So our development that's going up beside us, they have plans of local bathing areas, all that type of thing, from kind of a old graving dock. We could heat that and we could heat the apartments to a certain amount, but it is the local authority and that developer actually coming to us and basically requesting it. There's also wider plans on our Docklands campus to connect to district heating system, which we could route power over to that, or pipework over to that, or Canary Wharf as well.
And you'd give that heat away?
Yep, absolutely, yeah, absolutely. From a sustainability point of view, that's exactly where our plant operates a lot more efficiently if we do get rid of that heat and it's not going through our plant, and it helps other people as well. So 100%, it's a win-win situation.
Could you provide any more details on your choice of reduced carbon steel?
I can give you a whole marketing thing on it if you want. Yeah, no problem.
I'll see you.
Yeah, no problem at all. Yeah.
Great. Any other questions? I've got a quick one. What was your biggest challenge or surprise, or what is, if it's still ongoing throughout the project?
Every day is another challenge. Obviously, when you get into a retrofitting a building like this, it brings on challenges that you wouldn't have seen when you set off on this. I suppose our biggest facade replacement coming into it, we always knew we needed to do something to it, but we didn't realize it was going to be full replacement. That was one thing that hit budget line a lot at the end of the project and put time onto it as well. I think from navigating the market currently, I think is the hardest. Availability of materials, availability of expertise as well is a massive industry constraint at the moment. So that's been 100% the biggest constraint, the biggest issue.
Oh, and another question.
Hi, Simon Locker. You showed on your slide that you're building your own fibre routes into Telehouse South.
Yes.
How much success are you having with, obviously, sort of the existing Telehouse campus is one of the best interconnected with fibre carriers and things in London. How much success are you having getting them to extend their own networks down to the South building? Or?
A lot, yeah. Most of our connectivity partners have migrated down to South. There is still a few to follow over, but most are available in South as well. All of the big players are available in South. Yeah, I think we only have one floor live in South as well, so it is kind of it's nearing completion, but it's still not fully deployed from a customer point of view as well. So from our sales point of view, it's deployed almost to capacity, but from a sales fit out or a customer fit out, it's not really near any deployment at all that you of note, put it that way.
Are you using or offering your own ducts to help them get from the main campus to South?
I think we have
typically building it themselves.
We just obviously we have a partner that we have on those ducts at the moment, so we want to own our own. So obviously reduce our costs down there and just give customers a bit more availability with a bit more duct capacity in the ground as well. So I think from where we are at the moment, we have one of those ducts filled on each route. We have another 5 on each route as well. So there's expansion there and then our expansion as well. So we'll never be limited or cut off from a connectivity point of view back to the Docklands campus.
Great. Well, with that, thanks so much, Julian.
Excellent. Thank you very much, guys. Cheers.